Hi, so I'm going to create a new project in Code Configurator for microchip devices. This is MCC in VS Code extensions. MCC currently supports two content libraries, Harmony and Melody, and we are using Harmony here. So I happen to have PIC32CM, so we get information here, and I'm just going to use the part number here and create new MPLAB project. We name the project Hello World, select a custom location, projects, select the folder, select the part number, and with the compiler select XC32, though note ARM GCC is also supported natively in Harmony now. So here we just wait for a few more folders to be added. The build, CMake and output folders. Good to wait before opening MCC. So MPLAB, MCC, and here we have launch, which is just to open MCC, or configure associated project. That is handled in the multiple configurations videos in this playlist. So we're just going to launch and create a new config. The standalone config option is also handled in that multiple configurations video. Okay. So we'll just proceed with default values and create a new MCC config inside the folder, which is pretty much exactly how it works in MPLAB X. Okay, so the project opens and you see a project graph. If you see a project graph, it pretty much means that you are in MPLAB Harmony, and here you have a link to the GitHub and here to the main Harmony welcome page. So what are we going to do in the project today? We'd like to toggle a LED, 100 milliseconds, and literally do a hello world. So you can find some example with a UART. So we start under device resources, libraries, and look for a timer counter. There we go. Click on the context help here, and just one down. And there we can see we have a basic timer counter. Can operate in 3 modes: periodic delay, compare mode for generate waveforms, and capture to measure a delay, pulse, and frequency. So periodic delay is good for us. We'll keep on that basic mode. An interrupt is generated on period match, and in this case the callback is associated with using interrupts. Here we can see that there's a polling where you basically just wait for the timer to expire, then toggle a LED, and here the callback method. So we'll use the callback method, and let's set up the timer first. So we'll add this TC0 to our project, expand all, and we wanted 100 milliseconds. Any changes from the default are color-coded. Changes by the user are green, and changes made by the system are purple. You can see, okay, so only 1.3, and if we go all the way down, 100, you can see that works. If we go one less, no, it doesn't quite work. 87, okay, 100. So we stick with this. Enable timer period interrupt. So that's what we wanted, and so we can generate code. So this generating here should also remove that main, as you see that's happened, and we have source config of our peripherals, and here you have our main. Let's go back to our example code and paste. Okay, so this looks good, except we haven't set up a LED yet, and we see that it's TC3, so we can quickly replace TC3 with TC0. Okay, and now just LED. So going back here, from this kit page, we can find the development board, and here I want the primary user guide. Here you can see a range of different things. So for example, I can see peripherals, I can see the LED there. I actually want to go into the schematics, and here we can see our LED and button, and so the LED is on PA23. So here's MCC, and we have the standalone pin configuration. So we have a pins and a ports view. Port means that you get all the PAs in order. So PA23, GPIO, and we call it LED, and output. Now I want to also add a debug IO. So there's a table here of what the different debug functionality is. You can see there's a GPIO functionality on debug 2. If you're new to the Data Visualizer, have a look at visual debugging with MPLAB Data Visualizer to get an understanding of how debug IO can be used to trace program flow. So there's debug 1 and debug 2 on the switch, and that's PA22. So PA22, GPIO, debug IO, and also output. Okay, so now if we generate code, our error on the LED toggle should go away. It does, and we can now also debug IO toggle, and you can see that plab_port.h is where these are defined. Okay, so let us build. Here we can do a full build, and run and debug this kit. Okay, run. LED is blinking. Data Visualizer, MPLAB Data Visualizer. See debug IO. Add it to a plot. Using the scope mode because it is lovely for this functionality. So, and it's just remember to set our trigger. So there you can see the trigger, and there we go. Good as 100 milliseconds. Okay, what's the second part of Hello World? Well, in the next video we'll go on, we'll add the circom to get UART functionality and look at how one uses standard I/O in Harmony.